Hello and welcome to my channel. I am n.3ⁿ. Please, if you are new here, kindly subscribe to my channel, and if you have been watching my videos and if you not yet subscribed, please kindly subscribe us to go down mathematics community. In this lesson, we are going to prove using the principle of mathematical induction. So join me as we go through the induction step by step. Now, the question states that using the principle of mathematical induction, prove that for all n subset of natural numbers, 1 times 3 plus 2 times 3 squared plus 3 times 3 cubed plus up to plus n times 3 to the power n equals into bracket 2 times n minus 1 times 3 to the power n plus 1 plus 3 all divided by 4. Please kindly like the video, subscribe to my channel, leave your comment and also share. Now let's go through the steps. So we say that we should let the given statement be Pn, that is it, and then show that P1 is true, that is the base case. So if we take n equal to 1, we put 1 here. This will give us 2 times 1 minus 1 times 3 to the power 1 plus 1 plus 3 all divided by 4. 2 times 1 minus 1 is 1. Then 3 power 1 plus 1 gives 3 power 2, that is 9. 9 times 1 is 9, so we have 9 plus 3 divided by 4. That is 12 divided by 4. But 12 can be written as 1 times 3 times 4. This 4 cancel this 4 and we will be left with 1 times 3. That is what we have here. It is because of this, that is why I expanded the 12 like this. Okay, now we let pk be true for some positive integer k. Now we take pk, and that is we sum from 1 times 3 up to k times 3 exponent k. That is what we have here. That is whatever you see n, you put there k. And if we sum from 1 times 3 up to k times 3 to the power k, you will get this. That is substituting k here. Okay, now we also prove that pk plus 1 is true. So we sum from 1 times 3 up to k plus 1 times 3 exponent k plus 1. Now let's look at something here. You see that if we do that summation, if we sum this part represents pk, which is equal to this. So in place of this expression, you write pk plus 1 equals 2k minus 1 times 3 exponent k plus 1 plus 3 all divided by 4 plus k plus 1 times 3 to the power k plus 1. Wow. So now let's solve this. Here we have the LCM here to be 4. So we can multiply here by 4 and divide here by 4 so that you have the same denominator. If 4 cancels 4, you come back to what we have here. Or you come back to k times 1. Sorry, k plus 1 times 3 to the power k plus 1. So you have not done anything. So here we have the same denominator as 4. So we get the top to be 2k minus 1 times 3 to the power k plus 1 plus 3 plus 4k plus 4 times 3 to the power k plus 1. Now we have 3 to the power k plus 1, 3 to the power k plus 1. So let's send this 3 to this side. So we can send that 3 to this side, plus 3, because we have plus 3 here. So we've got that plus 3. Now let us factorize 3 to the power k plus 1 out. So you have 3 to the power k plus 1. Here it will be 2k minus 1 plus 4k plus 4 plus 3 all divided by 4. Now this gives 3 to the power k plus 1 times 6k plus 3 plus 3 all divided by 4. And here we can factorize 3 out. So we have 3 to the power k plus 1 times 3 times 2k plus 1 plus 3 all divided by 4. Wow, that is very simple. Now, we have pk plus 1 equals 3 to the power k plus 1 times 2 times k plus 1 plus 3 all divided by 4. Now, we are going to have 3 to the power k plus 1. That is here. This 3 has power 1, so we add power 1 to k plus 1. That is the product law of exponents. Now here we have 2k plus 1. We have 2n-1. So let's bring the 2k plus 1 first. So we have times. But here we need k plus 1. But this is 2k. So how do we get k plus 1? So we take 2 and multiply it by k plus 1. Because at the end of the day, we are going to get this if we put in k plus 1. If we put in k plus 1, we should get 2 times k plus 1 minus 1. That is, this k plus 1 is representing the n. Times 3 to the power k plus 1 plus 1. This k plus 1 is representing the n. Plus 3, all divided by 4. Wow. So here, we've gotten the k plus 1 plus 1. We've gotten it. It has left with this. So where you see this k, you should put there k plus 1. Very simple. So if we put there k plus 1, we will get 2k plus 2. But here you have 2k plus 1. So it means that we can subtract 1 from this. If we subtract 1 from this, it becomes 2k plus 1. So here we have 2 times k plus 1 minus 1. Then 3 to the power k plus 1 plus 1 plus 3. All divided by 4. That is very, very simple. As our pk plus 1. Hence, pk plus 1 is true whenever pk is true. So we've proved by the principle of mathematical induction that the given statement Pn is true. Thank you for watching. Please like, share, comment, leave more questions there for us to solve. If you have any way of solving it too, you can leave it at the comment section. Thank you for watching. Bye bye.